If f is Riemann integrable on closed interval AB, then for given epsilon positive, there exists a partition P of closed interval AB such that mod of this difference, summation I going from 1 to n f of ti delta alpha I minus integration from a to b f of d alpha. This is strictly less than epsilon where t is belonging to xi minus 1 and xi. Now here a single point t is belonging to this closed interval, right? And we need to prove this modulus to be strictly less than epsilon. We have given f to be a Riemann integrable. That means lower Riemann integral is equal to upper Riemann integral is equal to normal a to b f of d alpha. I will take the help of this, and we have given a partition and we need to prove this. How to start now? Now since this f is Riemann integrable on closed interval AB, and therefore for given epsilon positive, there exists a partition P of closed interval AB such that UPF alpha, I know that this is my result, minus LPF alpha is strictly less than epsilon. This is a result for if f is given to be Riemann integral, right? And for given epsilon, I'm having this partition, then UPF alpha minus LPF alpha less than epsilon. This is a result. Mark this as 1. Now let's define our capital Mi to be the supremum of fx over xi minus 1 and xi. And this is small mi is the infimum of fx over this xi minus 1 and xi. Now since this ti, let me take this ti which belongs to this closed interval xi minus 1 and xi for all I equal to 1 to n. So therefore this mi is less than equal to that property that whenever any point lie in this closed interval, then this infimum value of fx over this closed interval will be always be less than equal to the value of the function at this point, right? And I know that capital Mi, this is always greater than equal to the function of the value which at the point which belongs to this closed interval, right? As capital Mi is supremum of fx over this whole closed interval, the bigger one. So this is for all I equal to 1, 2 up to n. This you have to mention every time. So this implies, now I need to multiply delta alpha I again because I need that. So this is delta alpha I multiplied with Mi and f of ti into delta alpha I less than equal to capital Mi into delta alpha I for all I is equal to 1, 2 up to n. Fine. And now we have to take the summation. So let me take the summation also. I going from 1 to n, Mi delta alpha I less than equal to summation I going from 1 to n, f of ti delta alpha I less than equal to summation I going from 1 to n, capital Mi delta alpha I. So this implies this is nothing but your LPF alpha, and this is less than equal to this summation, let me write, and this is less than equal to UPF alpha. Fine, let me mark this as 2 since I know that LPF alpha is less than equal to the lower Riemann integral. Yes, now you remember. Very good. This is less than equal to upper Riemann integral, and this is further less than equal to UPF alpha. Very fine. Okay, but it is given to us that f is Riemann integrable, right? It is given to us f is Riemann integrable. So because f is Riemann integrable, I must change, I can replace this sign with equal to, because in that case these two integrals are equal and both are equal to simply integration from a to b f of t alpha, right? So this is LPF alpha is less than equal to, instead of writing that equal to sign, I'm just writing a to b f of d alpha as one and the same thing. This is less than equal to UPF alpha. Is it fine? Okay, let me mark this as 3. And now from second and third, what is 2? 2 is this. From here 2 and the result 3. From these two we get, yes, LPF alpha is less than equal to, that 2 is, that it is I going from 1 to n, f of ti delta alpha I. This is from 2. And this is from 3, that is a to b f d alpha is less than equal to UPF alpha. Okay, the next step, because I have to take the difference, I have to subtract this from this, which is required in our theorem, which is required to be proved. So this is taking the mod, of course, I going from 1 to n, f of ti delta alpha I minus a to b f of d alpha, right? This is less than equal to, yes, subtracting the last ones, which is UPF alpha minus LPF alpha. And with this from 1, this is strictly less than epsilon. So we get our result, summation I going from 1 to n modulus of f of ti delta alpha I minus a to b integral f of d alpha is strictly less than epsilon, where ti is belonging to xi minus 1 xi, this ti, right? Hence proved.